Okay, here we're going to take some information. They put it in a table just to save space, but we could write it out as separate kind of points or pieces of function information they're telling us. And then we're going to say which one of these could possibly work. Let's say even if we didn't say which one of these could possibly work, we'll kind of spitball our own graph first. But first thing we have to do is wrap our heads around what they're telling us. All right, so 5, -1. This is when you plug in x is 5, you get out for the function -1. So 5, -1 is a point. The rest of these, this is why I made them a different color, are values of the derivative. So they're telling you slope. So when you plug in x equals 4, it's telling you the slope is -1. So kind of like a down 1 over 1 sort of situation, like a -45 degrees if our graph was nice and even. And then here, if you plug in 6, it's telling you the slope is uphill, like an up 2 over 1, so a little bit steeper uphill than the downhill was. But that's over a couple more points too, it's right 6. And then here, they're telling you, right, not 0, they're putting this x through it, so this is their little like does not exist. And there's a couple ways it could have does not exist. You could have a cusp, right, one of those steep kind of points, not the top of a hill, bottom of a valley, like a teeter-totter, or you could have it be an infinite slope, like some kind of asymptote or some other situation where the thing is perfectly straight up and straight down. So at 5, -1, at least we know that's kind of an interesting point. All right, so we're looking for a function that goes downhill and then it hits either a vertical line or a cusp, right? It could be either. Could be straight up and down right here. So here's our slope information, and then it has to go uphill. Just from that, let's see what we can rule out here. So notice like this very first one, this one, the slope is going uphill and then uphill again. So both sides would have to be positive. So this can't do this. The point's in the right spot. In fact, if we want to look at it, all the points are theoretically could be 5, -1. So we can't rule out any of that. But this is a positive slope and a positive. We're looking for negative positive on our slope, right? So that one's out. Then we have, for a similar reason, see how this one's downhill and then it goes downhill again after a vertical does not exist? And so that one is negative slope, negative slope. We need one that changes slope, right? All right, here's one that changes slope. It goes uphill and then it goes downhill. So it's a positive slope, then a negative slope. We were looking for negative positive, right? Get our bearings here. This is 4 and this is 6. So it needs to be downhill and then uphill, not the other way around. So notice here's one that could work. At 4, maybe the slope here is -1. And at 6, maybe the slope here is -2. It's at least in the realm of possibility, right? We have a downhill and then an uphill, and we hit a does not exist, a cusp point in between. So that one's the only one that could possibly be the graph of our function, given just this minimal information that they told us about the function.